Galileo Galilei, 1564 to 1642. Chapter 1. Born Under the Stars, The Early Life of Galileo, 1564 to 1581. In the city of Pisa, Italy, the year 1564 brought with it the birth of a child whose mind would one day challenge the heavens themselves. Galileo Galilei entered the world in the modest household of Vincenzo Galilei, a musician and scholar, and Giulia Ammannati. The streets of Pisa buzzed with the daily rhythm of merchants, scholars, and townsfolk, unaware that in their midst a boy was growing who would gaze at the sky with eyes unafraid of its mysteries. From the earliest days, Galileo's curiosity was insatiable. As a child, he was not content with the explanations of adults, nor with the rigid doctrines of established thought. He examined the movement of water in fountains, the swing of pendulums, and the flight of birds with a precision and attentiveness that belied his years. His father, a man of intellect and discipline, encouraged this inquisitive spirit, nurturing in young Galileo a love of mathematics and music, the twin languages of order and beauty. By his adolescence, Galileo had already displayed an extraordinary aptitude for learning. While other children played in the piazza, he experimented with simple machines, crafted rudimentary telescopes, and observed the world with an analytical gaze. He pursued studies at the University of Pisa, initially drawn to medicine, but soon captivated by the allure of mathematics and natural philosophy. It was here, amid the grand halls of academia, that the seeds of his revolutionary thinking began to take root. The world he entered was one of rigid dogmas. Aristotelian thought dominated philosophy and science, dictating the accepted understanding of the universe. To question these principles was to court controversy. To observe, measure, and reason beyond established boundaries was to risk the wrath of tradition and authority. Yet Galileo's mind could not be confined. He asked questions that others dared not, tested theories that were considered immutable, and began to see the universe not as a fixed stage, but as a dynamic, discoverable realm governed by laws that could be understood. Even in these early years, the spark of rebellion against ignorance glimmered within him. He observed, he calculated, and he dreamed of a time when human beings could see the cosmos clearly, not through the veil of dogma, but with instruments, mathematics, and reason. The young Galileo, standing beneath the stars over Pisa, could not yet know the battles that awaited him, the discoveries that would shake the foundations of knowledge, or the profound legacy he would leave. Yet, in the quiet moments of wonder, peering at the movements of the planets and the flight of birds, the future scientist and revolutionary thinker took his first steps toward immortality. Chapter 2. A Mind Awakened, The Path to Discovery, 1581 to 1609. The city of Pisa and the surrounding Tuscan countryside provided a world full of wonders for a young Galileo. As he grew into adolescence, he carried within him a restless curiosity, a mind that could not accept answers without proof, and a spirit that sought patterns and truths hidden in plain sight. The late 16th century was a time of intellectual ferment. Yet, even amid the Renaissance brilliance of Italy, the cosmos remained cloaked in mystery and dogma. Galileo's quest was to unveil that hidden order. At the University of Pisa, he encountered the classical teachings of Aristotle, where every movement, every celestial body, and every force was predetermined and absolute. But Galileo's keen eye and sharp mind refused to accept unquestioned authority. He began conducting experiments of his own, dropping spheres from the Leaning Tower of Pisa to test gravity, studying pendulums, and examining the motion of bodies in ways that challenged the accepted wisdom of his professors. Where others saw impossibilities, Galileo saw patterns, numbers, and explanations waiting to be discovered. These were dangerous times for a thinker who dared to question tradition. To challenge Aristotle was to risk derision, career setbacks, and societal scorn. Yet Galileo pressed on, guided by reason and observation rather than fear. He began writing treatises on mathematics, mechanics, and motion, developing theories that would lay the groundwork for the physics of the future. His work was meticulous, precise, and revolutionary, though not yet fully understood by the world around him. By the early 1600s, Galileo's reputation had begun to spread. He received invitations to teach at universities and courts, where his intellect dazzled peers and patrons alike. But the true turning point came with a tool that would forever change humanity's understanding of the heavens: the telescope. Although rudimentary lenses had existed, Galileo's innovation magnified their power, allowing him to observe the night sky with unprecedented clarity. In 1609, Galileo pointed his telescope toward the heavens and witnessed wonders that no human had seen before. He observed the craters and mountains of the moon, revealing that it was not a perfect, unblemished sphere as Aristotelian doctrine claimed. He saw the moons of Jupiter moving with precise, predictable orbits, proving that not everything revolved around the Earth. He watched the phases of Venus, the countless stars of the Milky Way, and the shifting patterns of Saturn, realizing that the universe was far larger, more dynamic, and more complex than anyone had imagined. These discoveries were more than scientific achievements; they were acts of intellectual rebellion. Galileo's observations challenged centuries of entrenched belief, sparking curiosity, wonder, and outrage. To the Church and the guardians of tradition, his work was dangerous. To humanity, it was liberation, a glimpse into the vast, elegant machinery of the cosmos, governed by laws that could be studied, understood, and respected. By 1609, Galileo was no longer just a mathematician or philosopher; he was a revolutionary, a man whose mind had unlocked the hidden architecture of the heavens. And yet with every revelation came peril. The more he illuminated the universe, the more he threatened the authorities who insisted that human understanding remain confined to ancient texts. The stage was set for a confrontation that would define not only Galileo's life, but the future of science itself. Chapter 3: Eyes on the Heavens. Galileo and the Celestial Revolution, 1609 to 1616. The night sky had always been a tapestry of mystery, but in 1609, Galileo Galilei turned his telescope toward the heavens and forever altered humanity's view of the cosmos. With each observation, he revealed secrets the human eye had never seen: the craters and mountains of the moon, distant stars scattered across the black velvet of space, and the moons of Jupiter, dancing in precise orbits around their giant host. Every revelation challenged the worldview of centuries, unraveling the certainty of tradition and heralding a new era of scientific discovery. Galileo's discoveries were not merely technical, they were revolutionary in their implications. The moons of Jupiter, in particular, demonstrated that not everything orbited the Earth, a notion directly contradicting the Ptolemaic system embraced by the Church. He meticulously recorded his observations, creating detailed sketches and measurements that served as undeniable proof. The universe, he argued, was vast, dynamic, and governed by natural laws that could be observed and understood. Yet with revelation came resistance. The Church, guardian of centuries-old doctrine, viewed Galileo's findings with suspicion and fear. His evidence challenged deeply held beliefs about humanity's place in the cosmos, calling into question the literal interpretation of Scripture and threatening the authority of the Church itself. Scholars debated, theologians condemned, and whispers of heresy began to circulate. Galileo, aware of the peril, continued his work with courage and tenacity, defending his observations with logic, mathematics, and eloquence. In 1610, Galileo published Sidereus Nuncius, The Starry Messenger, a work that electrified the scientific community and scandalized the religious authorities. The book described his telescopic discoveries in vivid detail, accompanied by sketches that brought the distant heavens to life. Scholars across Europe marveled, students were inspired, and curiosity spread like wildfire. But the Church saw a threat. A man who revealed truth through observation could destabilize centuries of unquestioned authority. Despite the mounting tension, Galileo pressed on, driven by a belief that truth must be pursued, even in the face of danger. He corresponded with influential leaders, debated with scholars, and demonstrated the consistency of his findings. His telescopic revelations, craters on the Moon, the 4 largest moons of Jupiter, the changing phases of Venus, were irrefutable. Yet the opposition grew, fueled by fear, tradition, and the discomfort of confronting centuries of unquestioned authority. By 1616, the Church issued a warning. The Copernican model, which placed the Sun at the center of the universe, could not be taught as fact. Galileo was instructed to abandon the heliocentric argument, and the tension between discovery and dogma reached a critical point. But Galileo's heart and mind could not be silenced. He understood that knowledge was not a tool of power, but a gift to humanity, and that to deny truth was to betray the very purpose of inquiry. Galileo's eyes had opened to the cosmos, and though the forces of authority sought to blind him, he would continue to illuminate the heavens. Each night, as he gazed at the moon's jagged surface or tracked Jupiter's moons, he saw not danger, but possibility, the promise that human understanding could transcend fear, dogma, and ignorance. The celestial revolution had begun, and Galileo stood at its center, a pioneer challenging the heavens themselves. Chapter 4. The Trial of Truth. Galileo versus the Church, 1616 to 1633. The very heavens that had inspired wonder and curiosity now brought Galileo Galilei to the center of a storm that would define his life. By 1616, the Church had formally warned him. The Copernican heliocentric model, which placed the Sun, rather than the Earth, at the center of the universe, could not be taught as fact. To question the established Ptolemaic order was to challenge not only centuries of tradition, but the authority of God's representatives on earth. The weight of centuries pressed upon Galileo, yet his mind, ever restless, could not relinquish the truths he had uncovered. Galileo continued to observe, experiment, and write, understanding that the universe did not bend to human fear. In 1623, with the election of Pope Urban VIII, a man who had previously admired Galileo, he felt a renewed hope that his work could be published. Seizing the opportunity, he wrote Dialogue Concerning the Two Chief World Systems, presenting a discussion between defenders of the Earth-centered and Sun-centered systems. The book was brilliant, elegant, and persuasive, weaving observation, mathematics, and wit into a narrative that exposed the flaws of geocentric thought while demonstrating the rational beauty of heliocentrism.
Yet this very brilliance became his peril. Though written as a dialogue, the book was widely interpreted as siding with heliocentrism and subtly mocking church authorities. By 1632, Galileo had drawn the attention of the Inquisition, and the shadow of judgment loomed over him. He was summoned to Rome, his life poised between reverence and condemnation, genius and peril. The journey to the Eternal City was fraught with tension, every mile bringing him closer to the tribunal that would weigh his intellect against the Church's doctrine.
The trial itself was a spectacle of power and fear. Cardinals, theologians, and inquisitors scrutinized Galileo's writings, probing for heresy in every argument and nuance. The brilliant astronomer faced not a debate, but an interrogation, the stakes higher than any experiment he had ever conducted. He argued with precision, demonstrating the observational evidence of Jupiter's moons, Venus's phases, and the rugged surface of the moon. Yet no amount of reason could fully shield him from the weight of authority, tradition, and the fear of disruption. In 1633, the Inquisition rendered its verdict. Galileo was found vehemently suspect of heresy and forced to recant his support for the heliocentric model. He swore an oath denouncing the sun-centered universe, his hands shaking, but his mind still burning with knowledge that the earth did indeed revolve. For his punishment, he was sentenced to house arrest for the remainder of his life, confined to his villa in Arcetri, near Florence. Even in confinement, Galileo's spirit remained indomitable. He continued his work in mathematics, mechanics, and motion, developing insights that would influence generations. His experiments on falling bodies, pendulums, and the principles of inertia became foundational for physics. Though barred from publishing on heliocentrism, his ideas spread throughout Europe, inspiring thinkers, scientists, and astronomers who would eventually vindicate his vision. The trial was more than a personal ordeal. It was a dramatic confrontation between human curiosity and institutional authority, between observation and dogma, between the courage to see the truth and the fear of challenging power. Galileo endured not merely to survive, but to illuminate a path forward, proving that even in the face of condemnation, the pursuit of knowledge is an act of bravery. Through the shadow of trial and house arrest, Galileo remained a sentinel of reason, his mind a telescope through which future generations would see the cosmos in all its infinite complexity. His recantation could not erase the truth he had revealed, nor the spark of revolution he had ignited in the hearts of humanity. Chapter 5: The Science of Motion. Galileo's Lasting Discoveries, 1633 to 1642. Confined to his villa in Arcetri, overlooking the rolling hills of Tuscany, Galileo Galilei faced the cruel paradox of genius, barred from publishing the truths he had unveiled about the heavens, yet free in mind to explore the laws that governed the world below. The universe, he realized, was not only in the stars, but in the motion of bodies on Earth. Even under house arrest, Galileo's curiosity burned brighter than ever. In these years, he refined his experiments on motion, overturning centuries of Aristotelian orthodoxy. He studied the acceleration of falling objects, observing that all bodies, regardless of mass, fell at the same rate when resistance was removed.
With painstaking precision, he rolled balls down inclined planes, measured time with rudimentary water clocks, and recorded results with meticulous care. He discovered that motion could be described mathematically, that velocity, acceleration, and inertia followed natural laws that were universal and predictable. Galileo also investigated the pendulum, noting its remarkable property. The period of a pendulum's swing is nearly independent of its amplitude. He imagined clocks regulated by this principle, envisioning a future where timekeeping could be precise and mechanical. These were not mere experiments. They were visions of a world where observation, mathematics, and experimentation could replace superstition and dogma, where knowledge became a tool to understand, predict, and master nature. During these years, he composed his seminal work, Discourses and Mathematical Demonstrations Relating to Two New Sciences, a monumental treatise on motion, strength of materials, and the principles of mechanics. The book, though completed in 1638 and published in Leiden due to restrictions in Italy, codified his revolutionary insights. Galileo explained the laws of falling bodies, the parabolic trajectories of projectiles, and the principles of inertia that would later inspire Isaac Newton and generations of scientists. Each page was a testament to the power of reason over fear, to the persistence of discovery even in the shadow of oppression.
Though he could not freely explore the heavens without risking further censure, Galileo's work on Earth revealed the universality of nature's laws. He demonstrated that the cosmos and terrestrial motion were governed by the same principles: order, predictability, and beauty. In doing so, he transformed the scientific method itself, showing that observation, experimentation, and mathematics were the keys to unlocking truth. Even under the watchful eyes of the Church, Galileo continued to correspond with students, disciples, and fellow scholars across Europe. His letters conveyed wisdom, guidance, and encouragement, spreading his discoveries far beyond the confines of his villa. Though his body was constrained, his intellect traversed oceans and continents, inspiring a revolution of thought that would outlast the centuries. By the time of his death in 1642, Galileo had irrevocably altered humanity's understanding of the natural world. His work bridged observation and theory, challenging dogma with evidence, imagination with rigor, and fear with courage. Even as he lay confined to his home, his discoveries had set the stage for the modern scientific era, a testament to the power of the human mind, undaunted by limitation or persecution. Galileo's last years were not merely the twilight of a life, but the culmination of a mission: to reveal the truth of the universe, whether in the motions of planets or the paths of falling bodies. His legacy was etched not in monuments or titles, but in the enduring laws of nature, the triumph of reason, and the courage to see beyond the boundaries of his age. Chapter 6: The Telescope That Changed the World, Galileo's Lasting Impact on Astronomy, 1630s to 1642. Even in the quiet confinement of Arcetri, Galileo Galilei's mind soared among the stars. His telescope, once a simple instrument of curiosity, had become a revolutionary tool that revealed a universe far stranger and more magnificent than anyone had imagined. Through its lens, he had observed moons circling Jupiter, the rugged terrain of the moon, and the countless stars that made the Milky Way a river of light. These discoveries were not mere curiosities. They were revelations that demanded humanity rethink its place in the cosmos. Galileo understood that the telescope was more than a scientific instrument. It was a lens of liberation. It challenged centuries of dogma, opening the eyes of the world to a universe governed not by divine whim alone, but by natural laws that could be observed, measured, and understood. His observations became irrefutable evidence supporting the heliocentric model, a vision of the cosmos in which the Earth was not the immovable center, but a planet among others dancing around the sun. Even as he faced restrictions from the Church, Galileo's findings spread across Europe. Scholars, astronomers, and curious minds replicated his observations, confirming the movements of Jupiter's moons, the phases of Venus, and the countless distant stars invisible to the naked eye. The telescope became a bridge between imagination and reality, proving that observation could reveal truths far beyond what tradition or authority permitted. Galileo's influence extended beyond the heavens. His methods, systematic observation, meticulous measurement, and rigorous documentation, laid the foundation for modern scientific inquiry. Astronomers such as Johannes Kepler and later Isaac Newton built upon his work, expanding humanity's understanding of celestial mechanics, planetary motion, and the fundamental laws that govern the universe. Every observation Galileo made, every sketch and measurement became a stepping stone for the next generation of thinkers and explorers. Even as his body weakened with age, Galileo's eyes continued to seek the heavens. He taught his disciples to look carefully, measure precisely, and question boldly. He instilled in them the understanding that truth is not dictated by authority, but revealed through evidence, patience, and reason. The telescope, once a fragile instrument, became a symbol of humanity's capacity to pierce the veil of ignorance and glimpse the universe in all its grandeur. By the end of his life, Galileo had transformed astronomy from speculation to observation, from dogma to empirical science. The world would never again view the sky in the same way. The moon was no longer a perfect sphere. The planets no longer mere lights in the night, and the Earth no longer the immutable center of creation. Through Galileo's eyes, the universe had grown vast, ordered, and comprehensible, a cosmic stage where humanity could finally begin to understand its role. Even in his final years, the telescope and its revelations ensured that Galileo's name would endure. He had turned curiosity into discovery, observation into revolution, and a simple instrument into a beacon of human reason. The heavens, once distant and unknowable, had been brought within reach, and the spark of his insight would continue to illuminate minds for centuries to come.
Chapter 7. The Father of Modern Science. Galileo's Philosophical Legacy, 1633 to 1642 and beyond. Even in the shadow of house arrest, Galileo Galilei's mind remained unstoppable. His observations of the heavens and meticulous experiments on Earth had already begun to challenge centuries of unquestioned authority. But his most enduring gift would be the method he used to seek truth, a systematic, evidence-based approach that would define modern science. Galileo understood that knowledge was not a matter of belief or tradition, but of observation, reasoning, and experimentation. He demonstrated that the universe followed consistent laws and that these laws could be described mathematically. His work on motion, inertia, and acceleration transformed physics, providing a framework for understanding the natural world that transcended superstition and authority. By insisting that ideas must be tested and verified, he laid the foundation for a scientific revolution that would ripple through generations. The philosophical implications of Galileo's discoveries were profound. Humanity was no longer the unquestioned center of the cosmos. The Earth was a planet among many, and the heavens obeyed natural laws rather than divine whim.
This shift challenged not only theological doctrine, but the way people thought about knowledge, power, and reason. To observe, to measure, and to question became acts of courage and enlightenment. Even confined, Galileo continued to correspond with scholars across Europe. His letters discussed motion, mechanics, and astronomy, mentoring a new generation of thinkers who would carry forward his revolutionary approach. Young scientists emulated his insistence on rigor, precision, and skepticism, applying his methods to physics, mathematics, and eventually chemistry, biology, and engineering. His influence extended far beyond Italy, shaping the intellectual landscape of Europe and setting the stage for the Enlightenment. Galileo's insistence on the union of theory and experiment created a new philosophical approach that understanding must be grounded in reality, not authority. He demonstrated that hypotheses must be tested, observations verified, and conclusions challenged. This methodology, now fundamental to science, was radical in a time when tradition and dogma dominated thought. He did not merely reveal the universe, he changed the way humanity approached knowledge itself. By the time of his death in 1642, Galileo's legacy was secure, even if fully recognized only in later centuries. He had transformed astronomy, mechanics, and physics, but more importantly, he had transformed human thought. The courage to question, the discipline to observe, and the clarity to reason became hallmarks of the scientific method, ensuring that future generations could continue the pursuit of truth without fear. Galileo Galilei, the man who once peered through a simple telescope at the stars above Tuscany, had become immortal, not only through his discoveries, but through the revolution of thought he inspired. His life proved that knowledge is power, courage is necessary, and curiosity is the spark that drives humanity forward. Even in exile, even under restriction, Galileo taught the world that reason cannot be imprisoned, that truth will endure, and that the quest for understanding is eternal. Chapter 8: Vindication and Influence. Galileo's Legacy Through the Centuries, 1642 to 1700s. When Galileo Galilei passed away in 1642, he left a world still grappling with the shock of his discoveries. His telescopic revelations, his laws of motion, and his insistence on empirical evidence had challenged centuries of established doctrine. And yet, the seeds he planted would blossom into a revolution far greater than even he had imagined. Though he had faced censure and house arrest, the truth he uncovered could not be silenced. In the decades following his death, Galileo's writings continued to circulate across Europe. Scholars and mathematicians pored over his manuscripts, replicating his experiments and confirming his observations. His dialogue concerning the two chief world systems and discourses and mathematical demonstrations relating to two new sciences became foundational texts for the new generation of thinkers who dared to question and to reason. The heliocentric model, once condemned, gained acceptance among scientists as evidence mounted, and Galileo's courage was vindicated posthumously. Perhaps no figure exemplifies the impact of Galileo's legacy more than Isaac Newton. Building upon Galileo's observations and principles, Newton formulated the laws of motion and universal gravitation, providing a mathematical framework for the cosmos that Galileo had glimpsed through his telescope. The Earth, the planets, and the stars obeyed predictable laws,
and humanity now had the tools to understand the universe with unparalleled precision. Galileo had not only revealed the heavens, but had provided the methods by which future scientists could explore, measure, and predict the movements of celestial bodies.
Galileo's influence extended beyond physics and astronomy. Philosophers, engineers, and mathematicians drew inspiration from his insistence on observation and experimentation. His approach, the systematic collection of data, the careful formulation of hypotheses, and the rigorous testing of ideas became the blueprint for modern science. Laboratories, observatories, and universities across Europe became beacons of inquiry, guided by the principles he championed. Public perception of Galileo also shifted over time. Once condemned, he came to be celebrated as a martyr of reason, a symbol of humanity's courage to confront authority in the pursuit of truth. Statues, books, and commemorations honored his contributions, while his story became a moral and intellectual exemplar, a man who defied fear, challenged dogma, and illuminated the cosmos for all who would follow. Even as the 17th century gave way to the Enlightenment, Galileo's shadow loomed large over intellectual life. His telescopic observations and pioneering studies of motion continued to inspire debate, experimentation, and discovery. He had proven that knowledge is cumulative, that the courage to observe and reason can overcome centuries of misconception, and that one determined mind can change the trajectory of human understanding. Galileo's vindication was more than personal, it was universal. The earth was no longer the immovable center of creation, the heavens were no longer perfect and immutable, and humanity's capacity to comprehend the universe had expanded immeasurably. The Inquisition may have silenced his voice temporarily, but it could not extinguish the light of his discoveries, which illuminated the path for centuries of inquiry and discovery. By the end of the 17th century, Galileo's name had become synonymous with intellectual courage, scientific revolution, and the triumph of reason over fear. His life, once constrained by the walls of Arcetri, had transcended time, inspiring generations to observe, question, and understand the world as it truly is, a universe governed by laws, accessible to those brave enough to seek them.
Chapter 9. Galileo in the Modern Imagination. Science, Culture, and Inspiration, 1700s to Present. Centuries after Galileo Galilei's death in 1642, his legacy continued to resonate across science, culture, and human imagination. The man who had peered through a modest telescope from Tuscany had become an icon of reason, observation, and intellectual courage. His discoveries, once controversial and condemned, became cornerstones of scientific understanding, shaping the world in ways he could scarcely have imagined. In the 18th and 19th centuries, as Newtonian physics dominated scientific thought, Galileo's pioneering work on motion and inertia was celebrated as foundational. Students learned not only the laws he uncovered, but the methodology he championed: observe, measure, hypothesize, and test. Scientific societies across Europe revered his contributions, honoring him as the father of modern experimental science. His insistence on evidence over authority became a guiding principle, inspiring generations of scientists, astronomers, and thinkers to challenge assumptions and explore the unknown. Galileo's story also entered the public imagination as a narrative of courage against oppression. Artists, writers, and educators depicted him as a hero of reason, a man willing to risk everything in pursuit of truth. His struggles with the Inquisition became symbolic of the conflict between human curiosity and institutional authority, a story retold in plays, novels, and films. His life exemplified the power of intellectual bravery,
demonstrating that knowledge pursued with integrity can transform society.
In modern times, Galileo's influence is everywhere. Planetariums, observatories, and universities bear his name. His methods underpin scientific inquiry from quantum mechanics to space exploration. Astronomers trace the path of the planets he first observed, engineers study the mechanics he described, and physicists build on principles he discovered centuries ago. The telescope, once a fragile tool, has evolved into instruments that probe the edges of the universe, carrying forward Galileo's vision of observation and discovery. Even popular culture celebrates Galileo as a symbol of human ingenuity and determination. Films dramatize his celestial observations and confrontations with the Church. Documentaries showcase his revolutionary experiments. Books and exhibitions highlight both his discoveries and his courage in the face of adversity. Children learn of a man who dared to look beyond accepted knowledge, inspiring curiosity and wonder that transcend time. Galileo's life reminds humanity that the pursuit of knowledge is not always comfortable or safe. It may provoke fear, opposition, or even persecution, yet the rewards are transformative. A clearer understanding of our world, our place in the cosmos, and the principles that govern existence itself. His legacy teaches that observation, reason, and courage are inseparable companions in the journey of discovery. Through centuries of scientific advancement, Galileo Galilei remains an enduring figure, a bridge between the mysteries of the cosmos and the human mind, a symbol of reason confronting ignorance, and an inspiration for those who dared to question, explore, and illuminate the unknown. His influence, immortalized in both science and culture, ensures that humanity's eyes remain fixed on the stars, guided by the courage of the man who first dared to see them clearly.
Chapter 10. Eternal Vision. Galileo's Lessons for Humanity. Galileo Galilei's story does not end with the closing of his eyes in 1642. It continues in every telescope pointed at the heavens, every experiment conducted in a laboratory, and every mind inspired to question, observe, and reason. His life is a testament to the transformative power of curiosity, courage, and intellect, a reminder that truth is not dictated by authority, but revealed through evidence and reason. The lessons of Galileo's life are profound and enduring. First, the pursuit of knowledge requires courage. He challenged the dominant beliefs of his time, risking reputation, security, and freedom to reveal the laws of nature. His story teaches that progress often comes at the cost of confronting fear, tradition, and entrenched authority. True discovery demands resilience, persistence, and moral conviction. Second, observation and reason are the tools of human understanding. Galileo demonstrated that the universe is governed by laws accessible to those willing to look, measure, and think critically. From the moons of Jupiter to the acceleration of falling bodies, every insight he uncovered illustrates the power of inquiry grounded in evidence. His approach, the scientific method, remains the foundation upon which modern knowledge is built, guiding humanity toward ever greater understanding.
Third, the pursuit of truth is a gift to future generations. Though Galileo faced censure and house arrest, his discoveries spread, inspiring Newton, Kepler, and countless others who expanded human comprehension of the cosmos. He showed that knowledge is cumulative, and the courage to uncover it can reverberate across centuries, transforming not just science, but the way society perceives the universe and its place within it. Galileo's life also reminds us that adversity does not diminish genius. Even confined, he continued to explore, write, and teach.
His intellect could not be imprisoned, and neither can human curiosity be restrained by fear or authority. His vision, both literal and metaphorical, illuminated paths previously hidden, expanding the horizon of what humanity could know and imagine. Today, Galileo's legacy endures in every field of science, from astronomy to physics, from engineering to space exploration. His name is synonymous with intellectual bravery, observation, and innovation. He challenges us to confront our assumptions, to measure and reason, and to embrace curiosity as a guiding principle. He teaches that understanding the universe is not merely an academic pursuit, it is a moral and human endeavor, one that demands courage, patience, and imagination. Galileo Galilei looked to the stars and saw possibility. He looked to the earth and saw patterns. He looked to humanity and saw potential. His life is a call to continue that exploration, to expand knowledge, and to dare to question. In the eternal dance of the planets, the motion of falling bodies, and the endless stretch of the cosmos, Galileo's vision lives on, guiding generations of dreamers, thinkers, and pioneers. He proved that curiosity is unstoppable, that truth endures, and that one person's vision can illuminate the world. Galileo's life is not merely history, it is a beacon, a testament, and a guide for humanity, now and forever.